Hello, everybody. We are John and Graham. We are the authors of the book, whose lovely cover you can see up behind Graham there. Today, we're going to be having a conversation about asteroids. And I want to start by asking Graham about NASA's project, which I think is called DART, to blow up or disrupt some asteroids.
Yes.
So why are they doing this, Graham?
Well, I think they want to discover how, if there was a case of an asteroid which was threatening impact with Earth, they want to actually experimentally verify various technologies which would enable them to prevent that happening. And
are they actually going to blow it up, or are they going to move its orbit, or what? What do you think they'll be doing?
No, the blowing it up is the Hollywood engineering solution.
Oh, right. Right.
That's not really a good thing, because you can spread the damage and the disaster across the globe of the Earth if you try to fragment the thing. So basically, they're trying to move the orbit.
Right. And so what do these initials DART stand for then? How does that relate to the program?
It's double asteroid redirection test. Basically, they've chosen an object to make this test, which is a double asteroid. There's a primary in the center of this system called Didymus, and then a thing orbiting it, which is called Dimorphos.
So hence the D there is for double asteroid. Okay.
Yeah, yes.
So perhaps you can say a little bit more for our viewers about what asteroids are and where did they come from?
Well, basically, there's a region of space in the solar system between the orbits of Mars and Jupiter, and that's where the asteroids are. And they're sort of lumps of rock varying in size from about 900 kilometers down to just boulders and things. And they come during the formation of the solar system. The planet Jupiter, having such a large gravity field, prevented the formation of a planet in that region. So it's really the debris left over during the genesis of the solar system.
So they almost couldn't coalesce to form a bigger body. Is that the kind of feeling?
Yeah, that's what happened with some of the larger asteroids. But as I say, the gravitational influence of Jupiter perturbed that process. So you're left with an awful lot of debris that didn't coalesce. Right.
Of course, the term asteroid implies that they're star-like. So presumably that they must on occasions glow. Is that when they enter the atmosphere and burn up, or do they glow anyway?
I think they just shine by reflected light of the sun, as the planets do.
So is Earth normally in danger from being struck by asteroids? We've written in the book about a very large asteroid which struck the Earth during the Cretaceous and led to the extinction of the dinosaurs. But is Earth in danger of being struck by anything that big again, or in the near future?
Not in the near future, no. I mean, the likelihood of an event like that happening is very unlikely. So that was a very unlikely event. There was a 10-kilometer object came in and struck the Earth, and the consequences was the extinction of the dinosaurs.
So 10 kilometers across, that's quite big.
It is quite big, yes. And it was also... Sorry, I was just going to say it was also traveling at extremely high speeds. If these things come in, they're traveling at tens of kilometers per second, usually, depending on geometry. So they could actually traverse the denser part of the atmosphere, within a second or something, if this is going to happen. So there's huge amounts of energy, which dwarf our nuclear weapons, if you like.
So it wouldn't have, as it were, been burned up in the kind of classic way that we see as it came through the atmosphere. It was just too big to be destroyed in that way.
Absolutely, yeah. It came down and it managed to retain its integrity and struck a region of what is now Central America, with that consequence, as we said.
So how much would an asteroid that large, how much would it weigh?
Oh my goodness, that's a good question. I can't guess on that one. I would, but I do know, for example, this object which the DART mission is going to strike is 1 billion tons, and that's a midget. You know, that's just I can't remember exactly. I think it's 160 meters across or something.
All right, quite
So
little.
it's absolutely huge. If you think that, you know, mass scales with, you know, the cube of the size, as it were, absolutely enormous. Traveling.
So we're going to be talking about sort of 10 to the 15 tons, that sort of thing.
Yeah, something like that, maybe. Yeah.
That's big. That's
Yeah.
big. Now, we do hear of asteroids that have struck the Earth since then. What's the biggest you know of that's struck the Earth, for example, during human history?
Well, there's been a number of events. The most recent one was actually, I don't know if you remember, in 2013, there was a meteor exploded over the town of Chelyabinsk in Russia, and
Yep.
sort of smashed glass and all, caused injury and all this kind of stuff. That was a 20-meter object, which it was an airburst. It didn't reach the ground, fortunately. I think the most significant thing in perhaps recent history is 1908, the Tunguska event in Siberia, which demolished a forestation in an area of perhaps about as large as the internal area of the M25. If you know, if you know,
Yeah.
our people living in Australia perhaps won't know what that means, but anyway, but that's a huge explosion. That was also an airburst. Something that's hit the ground is about 50,000 years ago. If you maybe have heard of the Arizona crater or
Yes.
the Barringer crater, it's about just over a kilometer in size. And that was about a 50-meter object, which actually hit the ground and created that huge, So there's just a few examples there. If you say Google this kind of idea, you'll find quite a lot of events going on in recent and distant history, actually.
So I think the examples you've given us shows that relatively small objects compared, for example, to the Cretaceous dinosaur asteroid, can nevertheless cause a huge amount of damage. I mean, for readers not familiar with London, we could say that that the area that you were talking about is London and its far outer suburbs. It's
Absolutely.
long way out.
Yeah. I mean, a land impact can create fairly localized but devastating consequences. But another thing is that to realize is that most of the Earth's surface is sea. And if one of these things hits the sea, you get a tsunami with astounding characteristics, which manages to spread the energy and the pain across the globe.
Yes.
So, you know, I mean, if you think of places like the Bristol Channel, that is very much in danger of devastation if there happened to be an impact in the Atlantic Ocean, for example. So
the Seven Bore would be a midget compared.
Absolutely huge. And regions such as South India and Bangladesh, where there's very low-lying areas with very high population, if something landed in the Indian Ocean, that would again be cause huge human casualty. Yeah.
So objects do strike the Earth from time to time, but I guess mostly they're quite little and we don't really notice their impact. Or you know, how often do you think something actually reaches the surface of the sea or the land?
Again, a difficult question. You know, I'm sure there are events which occur which go unnoticed, shall we say, low energy events, so to speak. I think it's only the big ones that make the news, and I think actually it's fair to say that the Earth will be struck by something devastating. It's an inevitability, but it's just it's a very low frequency event, shall we say. So I think what NASA are doing are trying to, as I say, to develop technologies. So if we're faced with that problem, we can actually do something about it. So we can prove that we were cleverer than the dinosaurs.
Yes, yeah, yeah. You and I have discussed that dinosaur event, but just going back to it, it landed on the on a piece of land. But if it landed in the ocean, I guess the tsunami would have been quite enormous.
Yes, I'm sure it was global. The thing about a large asteroid striking the ocean is that the tsunami will reach every coastline in the world, because it sort of diffracts around headlands and all kinds of things. So it is absolutely devastating in terms of spreading the pain, really.
Yeah. So from what you're saying is that it seems to me that you're saying that the likelihood of an asteroid the size of the Cretaceous asteroid striking the Earth is actually very, very remote, but smaller, but nevertheless quite significant objects do hit us from time to time, and they do cause damage.
And absolutely, yeah. And as I say, something like the Tunguska event occurring, an airburst like that occurring over a city like London would be totally devastating, really.
Yeah. Would the NASA technology or proposed technology be able to deal with an event like that, with an incoming asteroid like that?
If there was the danger of a large object striking us, we would know about it probably years in advance. And so that means that if we can make small changes to the orbit over time, that would probably prevent a collision. So there are various ways. This idea of just socking the the dart thing is called a kinetic impactor. That is one way of doing it, but there are other ways of doing it apart from the Hollywood solution of blowing it up with an atom bomb kind of thing. I think we would be able to prevent that happening if we actually carried on and developed these technologies so that we could launch things as long as we've got enough time to change the orbit, because we can only make small changes, and those small changes can build up over a long period of time.
Yeah, so going back to the DART program, I think it's been very clear from what you've said that blowing up an asteroid is not a good idea. The fragments themselves could cause a lot of problems, but it seems that they're on the right track then, trying to alter its orbit or its direction of travel.
Yes, I think actually this is I've got a sort of a backdrop here with showing a picture of the DART spacecraft. Oh, sorry, I'm going the wrong way.
Yeah, I can see that.
So this is a picture of the central object in the background, and then Dimorphos, the smaller object, and the spacecraft itself. There is in fact another small spacecraft, which I think you might just see in the picture,
bottom right there,
which is designed to actually analyze the impact. Because the main spacecraft will actually die in that process, of course. And then what they're trying to do is along this line of effectively the impact will change the speed of Dimorphos by a tiny amount. And I worked it out as something like 1/100th of a centimetre per second, right? Because it's like a half-ton spacecraft versus a 1,000,000-ton object. So it's a very small effect. But the smaller change in speed produces changes in the orbit. So the impact occurs. This is the original orbit, and then the new orbit as well is in orange. And you can, for example, it causes a change in the orbit period, which is measurable. So when people look at this system in the future, they can actually calibrate the effect of the impact very, very nicely. And so they can then extrapolate that to other missions that they might have. So with different objects. Let me just say that Dynamis and Dimorphos don't pose any threat to the Earth. They're not sort of going, they're not in a, so basically fiddling around with this system, if you want to call it that, is a safe thing for them to do. But anyway, there we go.
But it's a good test bed for them to see
It's
whether
a very good test bed. It's quite ingenious, I think. I'm really fascinated by this, obviously.
you got. So our space engineer is really quite excited by this. That's excellent. So thank you so much, Graham. That's been really wonderful.
Well, it's
Thank you.
lovely to talk, John. And yeah, I hope people can get something out of this. It's an interesting subject.